Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at TCP Communication Process. We'll be discussing TCP Server Processes, TCP Connection Establishment, Session Termination, and the TCP three-way handshake analysis. This episode is part of my series on Introduction to Networks for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. As we talk about this, a server cannot have two different applications assigned to listen to the same port. You can have multiple applications on a server, but they need to listen to that different logical layer 4 port. They have to have different port numbers. Here, in this example, we have our server in the center. We have two different applications running. We have HTTP and SMTP. HTTP is our web server that's listening on port 80. We have SMTP, Simple Mail Transfer Protocol, that is our mail server. And so our server is hosting a web server and a mail server. They can run on the same computer, but notice they are listening to different ports. They are looking at the header, looking at that destination port number, that layer 4 destination port number, and they're going to decide, is that port 80? Then that goes to the web server. Is that port 25? That goes to the mail server. The active application on the server, it's assigned to a port number. And that port number, when it's assigned, means the transport layer is accepting segments in on that port number when it matches, and then it can process that segment. Any incoming client request with that socket number, remember the socket number is that incoming port number and IP address. It's a combination that makes that socket. It is then looked at, that server accepts it in, and then the data is passed to that application. And so then the web server, the mail server, whatever process you have, they can do what they need to do with that request. Down here, like in our example here, client 1 is making an HTTP request. They have their web browser open. They are going to look at a certain website. Notice the destination port here is port 80. It goes up here, goes to our mail server. The client chooses one of those random high number ports, those dynamic port numbers of 49152. The request goes to the server. The server sees, hey, it's looking for port 80. On port 80, I have my web server application. It takes that segment, reassembles it, it processes that web request, and then it replies back. Notice the HTTP response. Now, it's coming from the server, so it's headed this way. The source is now, it came from port 80. We switched the source and destination, so it came from the web server, and it's going to that random port here of 49152. It goes back to the client. The client remembers, hey, that I made this web request, this HTTP request on 49152. Let's send it back to the web browser, to the tab that made that request. Client 2 over here is making an SMTP request, Simple Mail Transfer Protocol. Notice destination is port 25. That's the well-known port for SMTP services. It sends it to the server. The server looks at that port, says, hey, it's port 25. This is an SMTP request. We are requesting to get our mail, sending our mail, something along that line. Then they process that and they make a response. Once again, we switch our source and our destination ports, and so it came from the web server, and then it goes to that random dynamic port that client 2 down here assigned to it. And now it can go down to client 2. Client 2 gets that PDU response back down here. It says, oh, it's destined for port 51152. That's when I originally sent it out, that was an SMTP request, so that's got to be a reply for my SMTP request. I'm going to go ahead and process that in my mail program at that point in time. That's how we look at these TCP server processes. TCP Connection Establishment. This is a 3-step process. We have our source over here on the left side. We have our destination on the right side. That's PCB. Or we could call this our client and server here. And how this process starts is the first step is the source sends a synchronize or a sync to the destination. What this sync does is, hey, I want to make a connection with you. Are you okay with that? And here's some information to go along with that. The server gets in that sync, and then it sends back its own sync request and an acknowledgement. The acknowledgement acknowledges that sync request from our source to start with. Then the server, because this is a two-way conversation, the server needs to then establish that connection going back. And so that's where sending the sync request from the destination back to the source happens. Once we get that, the client or the source receives that acknowledgement. It establishes that connection going in one direction from the source to the destination. Then it processes the sync request. The sync request, once again, says the server or destination would like to establish a connection with the client. Here's some information. The client then processes that, and at that point in time sends back an acknowledgement for the destination that happened there. Once we get that acknowledgement back at the server, we have our fully established connection in both directions. Because we established that TCP connection, we also have to terminate it when we are done. Termination is a 4-step process. Our client, once again, sends a finish request to the destination. That finish request basically says, hey, I'm done sending data. We don't need to maintain this connection anymore. Let's terminate that. Then the server responds to that finish request with an acknowledgement saying, okay, let's terminate that connection. That only terminates it in one direction between the client and the server. Then the server sends a finish request from the destination back to the source. And basically it's saying, once again, let's terminate this connection. The client, the source, receives that finish request in there, processes it, and then sends the acknowledgement back to the server saying, yep, let's terminate that. And when these 4 steps are done, your TCP connection has been terminated. TCP has in establishing our TCP connection, a 3-way handshake happens. And what this is it's the process in which it happens. The first step here is it makes sure that the destination is present, that basically that server exists. The second one is it verifies that server actually has a service we're going to be using. If we're making a web request, let's make sure it has a web server. And then the third thing it does is it lets the destination service know that, hey, we're going to make a connection with you on a port. And those are the 3 steps here, the 3-way handshake that happens. After we're done here, we're going to close the sessions. We're going to close our HTTP session, and then we close our connection. We close that TCP connection. In our TCP header, we have a field here called control bits. That would be right here. It's 6 bits long. This controls that TCP connection. We can have 6 different values in there, and these values associated with different control flags. That's what we call them. And as you can see on the left here, these are your 6 different control flags here. The first one is the urgent control bit. This identifies that, hey, this information is urgent. The second one is our acknowledgement. That was part of that 3-way handshake, basically saying, okay, that sounds good to me. Let's go ahead and do that. Third one here is the push. We're going to use it to push some information. Fourth one is the reset function. This happens when there's an error or a timeout, and we need to just basically reset that connection. The fifth one is the synchronize, or the sync, and that is the synchronized sequence number used in the connection establishment. And finally, it's the finished control bit. And basically, we are done with our connection, let's terminate it. These are the 6 control bits that we see. I hope you're liking this episode on TCP Communication Process. If you have the time, please leave a comment and let me know what you think about TCP communications. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. We're going to take a look at how this TCP three-way handshake happens. What we have here is some screenshots of a program called Wireshark. Wireshark looks at the actual information traveling across our physical layer, what the bits actually traveling across our physical wires of our network. And what it does is it takes it and it breaks it into the different processes that are happening. And what we're going to do is we're going to look at how this TCP handshake is established. Okay, to start with, TCP is a connection-oriented protocol, meaning that an end-to-end connection needs to be established. This needs to happen before data can be sent or received. A TCP three-way handshake, that initiates that connection. When that connection finally needs to be terminated, let's use the example of a connection to a web server, and you close that web browser on the client, that connection is terminated with two-way handshakes. A TCP three-way handshake, it involves 3 steps. That's why we call it a three-way handshake. Those 3 steps are a SYN, or a synchronize, synchronize and an acknowledgement, or an ACK, and finally, the third step is an acknowledgement, or an ACK. And once again, SYN stands for synchronization, and ACK stands for acknowledgement. First, the initiating host sends a synchronization segment. The responding host sends an acknowledgement and its own synchronization segment. And then the initial host sends an acknowledgement. And that makes us our first step of a SYN or a sync, then the second step of a SYN and an ACK, or synchronous and an acknowledgement, and then the third step of that ACK, or an acknowledgement. And we can see that here in this screenshot. If we look here at packets 10, 11, and 12, we have a SYN, or a synchronize. We have a SYN and an ACK, a synchronize and an acknowledgement, and then we have our final third handshake of an acknowledgement. This is that three-way handshake. If we look at that initial segment, that first step in the three-way handshake, we can see that the sequence number is 0 here. Right there, our sequence number is 0. The beginning of that three-way handshake is sequence number 0. Remember, computers start counting with a 0, so that first step is sequence 0. This is that first packet in that connection or conversation between 2 hosts, or in this case, between the host and the server. The sequence number is actually a random 32-bit number called ISN, or initial sequence number. This random number, or ISN, is chosen randomly at the beginning of each TCP conversation. This helps to protect against TCP hijacking. Wireshark takes that random 32-bit number and converts it into 0. It then increments the sequence numbers and acknowledgements. This makes it easier to read and follow segments in order using the Wireshark program. Let's look at a couple of the details for this original SYN segment. We can go down here into the packet details number. That's the bottom part of the screenshot here. We can see that the sequence number here is 0. And notice once again it says it's relative. It's truly a random 32-bit number, but Wireshark changed that into 0 to help us follow this through the process. If we look at the details, we can see that the SYN bit, the synchronized bit, has been set to 1. In the next packet, packet 11, that's the second line up here in our window, the server responds to the initial synchronization segment, and then I'm going to go to the next screenshot, and now we see that packet 11 is highlighted, so we got packet 11 right here. The server responds with an acknowledgement acknowledging sequence 0. So the original sequence number has been acknowledged, or sorry, incremented by 1, and now that is the acknowledgement number. We can see down here in the protocol's detail window, acknowledgement number 1. That's right here, acknowledgement number 1. And that's the relative ACK number. And this here is the next step in that original synchronizing sequence. And so think about this as one conversation here. We sent the synchronizing from the client to the server. The server is now sending that acknowledgement back. So we incremented that number, that sequence number, by 1. The server, okay, start over. The server has also sent its own synchronizing sequence, and that number is 0. And that's what we have right here. That is the starting of a second conversation. So the first one was from client to server and then server back, and now the server initiates its own synchronizing conversation, and that's what this one is starting right here. That is this one. It starts at 0 because computers start counting with 0 as the first one. And this is the initial step of the conversation going the other way from the server to the client. If we look down here in the flags, right here, we can see that both the synchronize and the acknowledgement has been set. Here we have the acknowledgement, and the next line down here actually is the synchronize. Got cut off on my screenshot, sorry. But this is actually the SYN down here, and that would have a 1. If we go to the next screenshot, in packet 12, once it here, again here is in blue, which is step 3 in the 3-way handshake, host 10.1.1.1, this is the source responds with an acknowledgement. We can see that right here. And if we look down here in the protocol's detail window, we can now see that the acknowledgement is 1. That was that second conversation started. Notice the original sequence, it stayed the same. And our acknowledgement number has now went from 0 to 1. Incrementing the server's synchronization segment by 1. You can see here that the acknowledgement bit has been set. This is the final phase in that 3-way handshake. Let's take a look at how that TCP connection terminates. Here we have packet 16, it's in blue, right there. That the server, right here, this is the server, SRV, is communicating with the client sent a segment with a fin or a finish and an ACK or an acknowledgement. In this segment, we have a fin and an ACK. We can see that right here. The fin or finish, that ends the conversation. That acknowledgement flag has been set since the 3-way handshake was first established. And every segment sent thereafter, that acknowledgement flag has been set. You can see that in the next packet, packet 17 right here, highlighted in blue again, that the host has replied to the server with an acknowledgement that that conversation has terminated. This is a 2-way handshake. The fin and an act. Right here, this is the first step. And then this here is the acknowledgement. If we look ahead here to packet 18, we can see that the host here sends the server its own fin or finish and acknowledgement. And then the server replies, and that's line 19 down here, with its own acknowledgement. And that gives us two-way handshakes for the termination of that. This is the first two-way handshake. This is the second two-way handshake to terminate that conversation. If I go back to the previous screenshot, and we look at the protocol packet details, if we look at the segment details, we can see here that the flags, notice the 1 for the acknowledgement, and then there is a 1 here, all the way down here, for the fin flag. Notice that the acknowledgements has went as high as 374. Indicating that these screenshots were generated from two different packet captures. You can see in these last two screenshots how the conversation ends with two-way handshakes. And once again, this here is one two-way handshake, and then this is the second one. It was my pleasure to provide you with this wonderful episode on TCP Communication Process. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on Introduction to Networks for the CCNA. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on Introduction to Networks for the CCNA. I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.